Hello, it's me again, Jim Clune, talking about botnets as far as how they affect organizations. I left off talking about logging and the importance of it, and then I wanted to get into something called egress filtering. Before I do that, I want to say a couple more things about logging. First, it's very important that you log to a central log repository, someplace that collects the logs immediately after the event occurs on whatever device is detecting the event. The reason for that is if the logs linger for a protracted period of time on a particular computer that might have, or network component, a firewall, that might have been hacked, the attacker has the opportunity to modify the logs and hide the event from your eventual discovery. So it's important, if you can do it, to get the event logged and off the box on which the event occurred as quickly as possible. We use syslog ng for that, but there are other tools for it. As far as most Unix environments are going to support this quite easily, and most networking equipment is going to support this quite easily. For Windows, intersect-alliance.com makes some snare software, snare for Windows and epilogue for Windows. Those have turned out to be very useful tools for grabbing this kind of event off of Windows boxes. For Linux, it's pretty much an easy thing to do. And I recommend it. Again, wherever the event occurs, get the event logged, log it locally, but also log it to some external syslog repository running some kind of software like syslog ng, so that the event has a chance of being preserved even after the targeted box has been hacked. It happens. All right, egress filtering. What's that? Egress, it's like filtering egrets, right? No, it's basically controlling what leaves a particular network. It's a nice way of saying denying internet access, really, except under controlled conditions. And that pretty much is what you have to do if you want to control botnet activity from within your company. That is the outbound connectivity that a botted computer is going to want to engage in with some external bot controller. Egress filtering will help you do that. It'll cut down on the ability of most malware to immediately connect outbound to a target site. Most malware is expecting to be in a home environment, no proxy servers, no outbound controls at all, and it's pretty much written that way. More advanced malware is perfectly aware of proxies and can get out through a proxy and through an HTTP session. That's a separate problem. But the first thing is to limit the amount of outbound activity, uncontrolled activity, that your population, your desktop user population, your laptops, etc., have. And the best way to do that is to block most of it. That is, not allow your desktop users to have unfiltered direct outbound connectivity to the internet, and instead force them through proxies. Force them through proxies like blue coat proxies, web proxies of some kind, such that a home user computer, or rather a desktop computer in your organization, cannot make direct outbound connections to the internet. It simply is blocked for that. Looking at the log traffic for those denies, the attempts to go outbound directly, will reveal quite a bit about the malware that's inside your company. And I see this all the time, where computers inside are infected with something. They're on a botnet. They've come inside from the outside, been brought back in by their owner. They're plugged into the corporate network, and now they try, when they're powered up, to connect outbound directly to what they're used to seeing on the outside. Because they're not allowed to go directly out, all web traffic is supposed to go through a web proxy. They create a deny event in the firewall logs. That's useful for detecting the fact that the source computer has malware on it. It works pretty well. So the idea is that you block all direct access from for your desktop users to the internet, and force them to have their environments configured to use some kind of proxy server. And there's lots of different proxies. There's Squid, open source proxy. Microsoft has its ISA proxy, and Bluecoat, bluecoat.com, is a fairly well received in kind of industrial strength proxy that receives information about malware sites from other blue coats all around the world, keeps itself updated, and does a reasonable job of trying to deny access to known malware sites. You're not going to stop this from ever happening. Sophisticated malware will get out through your environment eventually, no matter what you do, but you can certainly control and limit the amount of it by introducing egress filtering to prevent most traffic from getting out unimpeded simply because it tries to go directly out and not through the proxy. There's an article on the Wikipedia that you can look at on egress filtering. That's EGRESS space filtering, and I recommend it to you. The fundamental belief here is that you have computers that have malware on them that want to talk to controllers outside on the internet. You have to make that as difficult as possible for them, which also means making things a little difficult for your end users. I find that the best way to introduce this is gradually, with a lot of instruction and a lot of presentation as to why this has to be done. Some log traffic at that point showing what's really going on tends to motivate people to get behind the filters. But that's it. That's the whole topic on egress filtering, and I may add to it later, but I wanted to get that out now. After this is over with, what I want to talk about is a little bit about the architecture of a corporate organizational environment, what needs to happen there in the era of botnets to make the opportunity for a botnet to take hold inside your corporate data center less likely, and to maximize the potential of you detecting it. That's it, and that's what I'll be talking about next time. Thanks for your attention. See you in a bit.